The containment of smoke and other toxic gases during a fire is a crucial element of fire and life safety. At times, it's easy to get bogged down in the little details of life safety compliance. During this process, we tend to lose sight of the bigger picture and the reason the codes were created in the first place. When fire barriers are non-compliant, not only are facilities compromised, but so is the safety of the building occupants. So how do we best define fire stopping? It's a process, the process of restoring an hourly fire endurance rating back to a fire barrier that lost its rating from an opening created in it. Fire stopping restores the rating at a barrier. Fire stopping material is tested and approved. The building codes have very clear requirements on passive fire protection. Fire investigative reports have shown that unprotected or improperly protected penetrations and joints cause millions of dollars in property damage and contributed to the loss of life and injuries due to the uncontrolled migration of fire, smoke, and gases. In order to promote life safety and property protection, the National Building Codes include fire testing and performance requirements for penetration fire stop and fire-resistant joint systems and rated duct systems. Chapter 7 of the International Building Code provides detailed requirements for fire resistance rated construction, including structural members, walls, partitions, and horizontal assemblies. Other portions of the code describe where certain fire resistance rated elements are required. The chapter specifies how these elements are constructed, how openings in walls and partitions are protected, and how penetrations of such elements are protected. The 5 fire protection concepts for fire and smoke resistance rated construction in the ABC are structural integrity maintenance, fire spread limitations, means of egress protection, radiant heat exposure protection, smoke movement restriction. Building codes control and include fire safe design and the fire prevention into the construction of the building and systems that are installed. Fire codes dictate prevention on an ongoing basis beyond the period of initial design and construction. It can best be said that the building code is a construction code. The fire code is a maintenance code. Referencing Chapter 7 of the 2018 International Fire Code, Chapter 7 provides requirements to maintain the fire resistance ratings of building elements and to limit fire spread. In 701.6, Owner's Responsibility, we read the owner shall maintain all inventory of all required fire-resistant rated construction installed to resist the passage of smoke, and the construction included in sections 703 through 707. Such construction shall be visually inspected by the owner annually and properly repaired, restored, or replaced where damaged, altered, breached, or penetrated. Again, referencing the IFC in 701.2, the provisions of this chapter shall govern the inspection and maintenance. Therefore, we make the statement that the fire code is a maintenance code. Fire stopping is critically important in healthcare facilities because many occupants have limited mobility and could not easily evacuate in the event of a fire. Hospitals and other healthcare facilities that perform surgery or offer inpatient care are designed to protect occupants by a process called defending in place. By contrast, most occupants of an office building can evacuate themselves without assistance, thus the higher standard for healthcare facilities. Healthcare facilities must be designed with additional features that protect the occupants in the event of a fire. The Joint Commission and the Center for Medicare and Medicaid, the two primary agencies that regulate hospitals and healthcare facilities, require that buildings comply with the National Fire Protection Association Life Safety Code, NFPA 101, and the associated life safety chapters. Many healthcare facilities initiate a barrier management program, restricting the access above ceilings to prevent unknown breaches in fire barriers. Barrier management programs are discussed in more detail in another section. National fire protection groups throughout the country have identified these 3 elements of fire and life safety. Number 1, notification. 2, compartmentalization. 3, suppression. The containment of smoke and other toxic gases during a fire is a crucial element in fire and life safety. Compartmentation is identified as a passive fire protection measure. The spread of fire can be restricted by dividing a building into separate compartments with fire-resisting walls and floors, thereby increasing the availability of escape routes for the occupants. The IBC lists a variety of fire resistance rated separation types. Each unique separation type serves a distinct purpose as reflected in its design detail. Fire resistance rated separations listed in the IBC include firewalls, fire barriers, fire partitions, smoke barriers, exterior walls, and horizontal assemblies. Fire protection systems can be broken down into two prime categories, active and passive. An active fire suppression system includes mechanical systems that are designed to extinguish fires after they have been started, such as sprinklers. But active systems do not control propagation of smoke and gases, the leading cause of death in fires. Passive fire protection functions to contain fires within the area in which they start, preventing a loss of life by preventing the products of combustion, smoke, hot gases, flames, from spreading throughout a building. Passive fire protection refers to fire-resistant construction and the code-required third-party tested Firestop systems that are installed to restore the rating of fire-resistant construction. Passive fire protection systems are an important part of a comprehensive, balanced approach to fire protection. Passive fire protection focuses on containment and uses compartmentalization to prevent or slow the spread of fire from one compartment to another. Fire stops have been receiving more attention in recent years, especially from building inspectors and fire marshals. This is not surprising. Statistics have shown that inhalation of smoke and toxic gases account for 75% of all fire-related deaths, and the fact that about 57% of the people killed in fires were not in the room with the fire's origin underscores the importance of good containment, which can only be achieved with fire-stopping systems correctly installed and proper maintenance. Smoke can fill a 20 by 20 foot room through a pencil-sized hole in less than 3 minutes. Over half of fire-related deaths occur in rooms where the fire did not originate, and 3/4 of all fire deaths are caused by smoke inhalation. This is why proper fire stopping is so important. There have been several major fires in history that reveal the true consequences of what happens when firewalls are neglected or fire stop systems are not properly installed. On March 22, 1975, a fire broke out in Browns Ferry nuclear plant when a worker tried to test the material for smoke containment. It turns out the material being used for Firestop was a urethane foam, which was highly combustible. Fire was put out, but this could have been a major disaster, as more than 1,600 electrical cables were damaged, affecting 628 important circuits. These circuits controlled the nuclear power plant. November 21, 1980, a fire breaks out at the MGM Grand Hotel in Las Vegas, Nevada. It was later determined that it was started by heat from an electrical system that was within a combustible concealed space. 85 people were killed in that fire and nearly 700 were injured. While the fire primarily damaged the ground floor casino and adjacent restaurants, most of the deaths were caused by smoke inhalation on the upper floors of the hotel. One of the life safety issues was openings in the vertical shafts, stairways, elevator hoistways, and the seismic joints, which allowed toxic smoke to spread throughout the building. Later newspaper articles indicated there were 83 code violations found in the building. Not more than 3 months after the fire, the state's building and fire codes were revised to have the most stringent fire sprinkler and life safety requirements in the country. Fire stopping helps to contain smoke and toxic gases to help stop it from spreading to other areas of the building. We need to take into consideration what fire stopping does and why it's important that the penetrations are properly sealed. Fire stopping can increase the availability of escape routes for occupants and ultimately save lives. Fire stops are a critical component in the fire protection system and are necessary to slow the spread of fire, smoke, and gases during a fire and to give occupants more time to escape. Fire barriers can have any number of penetrations that, if not properly sealed, can compromise their fire rating and thus their ability to contain smoke, gases, and flames. These include through penetrations, which pass all the way through the fire barrier to accommodate electrical wiring, plumbing pipes, and parts of the building's mechanical systems. Membrane penetrations, which pass through only part of the barrier, such as outlet boxes, sink drains, or a conduit that leads to an opening to a space in a wall or a ceiling. Building joints, where building elements meet with fire-resistive rated wall or floor assemblies. Junctions between fire-resistance rated walls or floor assemblies. Openings made in anticipation of future needs. And fire stops that have been reopened. Areas that require fire stopping through penetrations, blank openings, membrane penetrations, construction joints, perimeter fire barrier systems. Within the IBC, the areas that require fire protection are listed in 714.4, 714.5, 6, 714.5.4. These code sections address not only the type of penetrations required to be protected, but also the acceptable methods of protection. The fire resistance rating of the Firestop system must equal the fire resistance rating of the penetrated fire separating assembly or floor assembly in which the Firestop system is installed. With a few exceptions, the methods and materials used in the penetrations, joints, and duct enclosures are tested as a system to demonstrate the methods and materials function as fire containment for the required fire resistance rating. A modification to a tested system voids the rating of that system. The IBC requires in 714.2 a listed penetration Firestop system shall be installed in accordance with the manufacturer's installation instructions and the listing criteria. So how do we get to these listings? Well, we have to have testing. As a first step, the products must be subjected to relevant standardized fire tests for each desired installation configuration. The listing laboratory will publish the installation details and limitations for each certified product based on the fire resistance rating that is achieved in each of the fire tests. There are several independent testing laboratories, also referred to as third-party testing agencies, which conduct the fire testing of Firestop and duct enclosure systems. One of the most important tests for Firestop systems is ASTM E814, Standard Test Methods for Fire Test of Through Penetration Firestops. In addition, UL has developed UL 1479, Fire Test of Through Penetration Firestops, and UL 2079, Test for Fire Resistance of Building Joint Systems. The fire test results are usually included as design listings in the fire resistance directories published by testing laboratories. Testing criteria information is typically listed on the UL system design sheet that you will receive in the field during your inspection process. Certain key elements will be identified. Specific are the F rating, which is the rating that prohibits the flame passage through the system for a duration of a fire test. The T rating is a maximum temperature rise of 325 degrees Fahrenheit above the ambient on the non-fire side of the tested penetration. L rating concerns air leakage. W rating is the hose stream test. All systems must undergo the hose stream test. The hose stream test is usually the most difficult step in validating the performance of Firestop. A UL listed system product bears the seal of UL. Ultimately, it's the authority having jurisdiction who approves such systems. The HJ must approve Firestop system details and Firestop products. Hence, Firestop system details and materials should be included on the plans and specifications. Manufacturer cut sheets are often accepted if they are generated by an approved testing agency. If details, products, and specifications are not sufficient to provide clear directions to the general contractor and Firestop installer, the submittals should be noted as incomplete and returned to the designer to be resubmitted with the required information. When the plans and specifications are clear and complete, most field problems with Firestop systems can be avoided. The building code requires that sufficient information be provided to the building inspector to conduct required inspections. Required inspections include on Firestop. Typically, this is contained within the project submittal package and should be reviewed during the time of plan review. As previously discussed, the building code requires in Chapter 1 that sufficient information be provided to conduct necessary inspections. This includes information concerning Firestop. The pre-construction meeting is the perfect opportunity to initiate discussion on the coordination of work among the trades, the general contractor, and the inspectors. This discussion is important since the application of Firestop protection systems is affected by the work of many trades. An early discussion of who is going to be responsible for restoring the fire resistance ratings will eliminate aggravation and expense later in the construction process. The pre-construction meeting should also be used to agree upon all the penetrations to be protected, to schedule the trades to work with the Firestop installers, schedule Firestop inspections accordingly, and agree on whether the building or fire inspector will be conducting the inspections. True or false? Penetration Firestop is required to have special inspection for Category 2 facilities. So fill in the blanks. How do we address the intersection created at a fire barrier and a non-fire rated assembly? So this is going to conclude this section of the training on Firestop. Remember, there were 5 different sessions. I ask that you go through each one. Also, be sure to like and subscribe to this YouTube video. We appreciate that. It helps us along the way. And if there's any questions you got, email me. My email's showing up here on the screen for you. Reach out to us anytime, dolesmichael@gmail.com. We're in South Carolina. If we're in an area that we could come and visit with you or your group, we'll be glad to do that. So just sit back and go through all the videos. Try to glean as much information as you can. And again, this is, pretty much just my experience and my opinions on some things. We'll give you some really good references. And I wish you the very best with everything you're doing.